Okay, hello everyone. Last time we did truth functions. That is to say, we looked at the values associated with and, or, implication, biconditional, or triple bar, and negation. Here we're going to learn truth tables. And the first exercise, 6.31, pages you should have read, 354 to 361, asks whether these formulas are tautologous, self-contradictory, or contingent. Then we'll compare two formulas in the next exercise. Then we're going to put arguments into truth tables. So, number 2 there, the first one assigned, goes like this. G implies G, and implies G. Okay, so one letter, and we have to see whether that's self-contradictory, contingent, or tautologous. So, if there's only one letter, there's only two truth values, true and false. So, you know, in this case, true, false, true, false, true, false. Wherever I see G, the only possible values for G, one letter, are true and false. Now, here's what I can do. By the way, this is in parentheses, which means the major operator is the conditional sign or the horseshoe outside the parentheses. So true implies true is true, true and false implies false is true. Now I have to, in order to get the values for this, I have to look at this antecedent and that consequent, and that's how truth tables work. True implies true is true, true implies false is false. A contingent formula is one that is true on some lines but not all lines, and this is false on the second line under the main operator, so this is, I'm going to abbreviate, contingent. Okay? 3, S implies R, and, let's say in conjunction, S and not R. Okay, so we have two letters and two possible truth values, so when you have that, 2 to the second power is going to be 4 rows. I know then that under S I have to put true, true, false, false. Under R, true, false, true, false. Wherever I see S, true, true, false, false. And under R, true, false, true, false. The reason being, that gives me all possible sets of value under S and R. True, 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 false, false, true, false, false, if you look at those 4 rows. All right, before I can get the major operator, which is where the values are, where I'm keeping score ultimately, so to speak, I want to get the values inside the parentheses. True implies true is true, as we know from last time. True implies false is false. False implies true is true. True, false implies false is true. So I'm going to make it easy on my eyes and just circle that one. And I know I'm going to need it later when I do the conjunction of these two conjuncts. Not T is F, not F is T, not T is F, not F is T. Then I have a dot here, so that's S is true and R is false. I'm not interested in the R, but the place where it's false under the negation sign. So T dot F is F, T dot T is T, F dot F is F, F dot T is F, according to the rules for conjunctions. Now, the main operator under that conjunct is the dot. The main operator under the implication, the first implication was the implication sign. So it's true dot false is false, false dot true is false, true dot false is false, true dot false is false. If something is false on every row, that means it's a self-contradictory formula. So I'm going to put an abbreviation again, self-contradictory. It's inconsistent with itself. So false on every line, there's no way that that truth table shows that that formula can be correct. Okay? Then we're going to skip to 5 and 6. You can obviously just stop this if you want to follow my explanation more slowly, but now I have to move on. Okay, so 5 and 6. 5 has, in parentheses, K is false implies H. And then we have is equivalent to, triple bar, not H or K. Okay, so let's see what that ends up with. Well, K and H, again, we only have 4 rows, so true, true, false, false. Under H, true, false, true, false. Under H again, true, false, true, false. Why? Because that's what H took last time. When I see K again, true, true, false, false. So the first letter I come to with 4 rows, we get 2 trues and 2 falses. The second letter, in this case, A, true, false, true, false. That will give me all 4 combinations on the 4 rows. All right, so then I have to do not K, not true is false, not false, not true is false, not false is true, not false is true. Then I can use this row here, the first negation sign, to imply the H. So it's F implies T is T, F implies F is T, T implies T is T, T implies F is F. I'm going to circle that again because I know I'll be using that later. H or K, true or true is true according to disjunction, true, true, and false. I know I'm going to be, I don't want to circle that yet, I'm going to negate. The negation goes to the disjunction sign or the wedge. So not true is false, not true is false, not true is false, not false is true. So then I've got the main operator here is the negation, and I've got my main operator here, the implication. Are they equivalent? Is true is not equivalent to false, that's false. True is not equivalent to false, that's false. True is not equivalent to false, that's false. False is not equivalent to true, that's false. So they're false on every row. What did we say that meant? That is a self-contradiction. All rows were false. Okay? That's the way that one worked. I think I can fit the other one down here. I'll leave that up for a second. But this one says M is true implies P is true, or P implies M is true. Okay, so I can fit the 4 rows, I think. True, true, false, false, true, false, true, false. Under P again, true, false, because that's how I found it the last time. Under M, true, true, false, false. Okay, M implies P, true implies true is true, true implies false is false, false implies true is true. True implies true is true, false implies true is true, true implies false is false, false implies false is true. The disjunction says that these 2 main operators, one of those must be true in order to get a true. So true or true is true, F or T is true, T or F is true, T or T is true. If it's true on every row, what do we call that? A truism is the word once upon a time that was used. Now it's called tautology. So it's something that's true by definition. So M implies P or P implies M is true on every row, therefore a tautology. So we've seen every combination. We've seen contingent, self-contradiction, and tautology. I'm going to do one with 3 letters in it. That's number 9. Okay, I'm going to skip by 8 because that has 2 letters, but we should do one with 3 letters because 3 letters has 8 rows. Okay, that's number 9. Okay, so 9 is brackets, X implies parentheses, R implies F, equivalent to brackets, X implies R implies F, close brackets. Okay, let me just see something here. That seems like an operator might have been left. That's okay. An operator might have been left out there. I just want to make sure. Yes, there should have been a parenthesis there. That's what I was needing. Okay. Otherwise, that would have been an ill-formed formula. So, since there are 2 letters, or 2 truth values always, true and false, and 3 letters, so that's 2 to the 3rd power, that's 8 rows, that's how you know. Under X then, 4 truths and 4 falses. Under R, we're going to alternate true, true, false, true, true, it should have been, false, false, true, true, false, and false. And when I see the 3rd letter, F, the 3rd different variable, I'm going to alternate true, false, true, false, true, false, and true, false. I see X, I've seen it before, 4 truths, 4 falses. Under R, 2 and 2, truths, 2 falses, 2 truths, 2 falses. Under F, alternate true, false, true, false, true, false, true, false. Okay, now we've set it all up. That seems like the most laborious part. I can't get the main operator here without getting what's inside the parentheses. So R implies F, true implies true is true, true implies false, true, 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 false, true, and true. Okay, then, in order to get the second column here, I have to do this one here, which would be the fourth. X, I have to get X implies the fourth. So true implies true is true. True implies false is false. True implies true is true. True implies true is true. False implies true is true. False implies false is true. False implies true is true. False implies true is true. Okay. The main operator here is that one. I'm circling that because I know that I'll need it. Now, true implies true is true. True, false, false. The rest should be true. False implies anything is true. True, true, and true. Now, in order to get the main operator here, I have to look at the X column implies the F column. So true implies true is true. True implies false is false. True, false, true, 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 and true. Okay. Well, what are the main operators? Not this conditional, but that conditional, the next to last column. And so I use this one here. True implies true is true. False implies false is true. True implies true is true. True implies false is false. True implies true is true. True implies false is false. True implies true is true. And it looks like true implies false is false. So in that case, this is a contingent formula. That is to say, not under every row is it false, not every row is it true. So it's neither tautologous nor self-contradictory. So in that case, by process of elimination, it is contingent. All right. Okay, so this time, we're going to, at 6.32, there's several possibilities. I'm not reading from here now. Equivalent, contradictory, consistent, or inconsistent. And you've been giving several formulas. So number 2 that's assigned, you have F dot M, and you can compare that with its negation F or M. Okay, so, and how are they going to be? All right, so F and M, I have 2 variables, and then so 2 values and 2 variables, that's 4 rows, true, false, true, and false. Under F, I'll see true, true, false, false. Under M, true, false, true, and false. Okay, F dot M, true and true is true. The rest should be false. In conjunction, they both have to be true. Go back to your truth functions if you don't know that. True or true is true. True or false is true. False or true is true. False or false is false. Now, the negation doesn't go to the F. The in parentheses negation goes to the disjunction. Not true is false. Not true is false. Not true is false. Not false is true. Okay, so the main values under the dot were here. The main values were here. Now, are they ever the same on one row? It looks like T is the negation of F, F and F, F and F, and F and T. Actually, those are what we call inconsistent. Inconsistent means they're never true on the same row. You don't find T, you can see the definition for inconsistent, but you don't find both formulas true on any one row. Wherever there's a true, there's a false with the other formula. So those are inconsistent formulas. Number 3, I'm going to fit that in down here. Leave that one up there a bit. 3 is K is false, implies L, and we're going to compare that with K implies L is false. Okay, so we're going to have 4 rows here. True, true, false, and false. And we're going to have true, false, true, false, true, true, false, and false, true, false, true, false. Okay, not K, false, false, true, true. F implies T, T, F implies F, T, T implies T, T, T implies F, false. I know I'm going to need that, so I'll circle that. Not L, F, not F is T, not T is F, not F is T. T implies F is F, T implies T is T, F implies F is T, F implies T is T. What do we know about these values? Well, T and F, T and T, T and T, F and T. Are they T on any one row? Yes, on the second row, they're consistent. That is to say, both have a truth value on one row, that being the second. Looks like the third too, right? But you only need one to establish consistency. So those two formulas are consistent, which means to say they have the same, they both are true on some one row, okay? We'll skip to 5. These are, if you have a question about any of the things I'm doing, go back to the truth functions of the last lecture, 6.2, or you go back to the reading on those pages, and that'll explain how this is being derived. Okay, so number 5 is not a triple bar X, and then what's the relationship between that and this longer formula? X dot not A, disjunction, A or not X. Okay, well, okay, true, true, false, false, true, false, true, false, true, false, true, false, true, true, false, false, true, true, false, false, and true, false, true, false. Well, the first part should be pretty easy. I can't get the triple bar until I get the negation, so not true is false, not true is false, not false is true, not false is true. What's the relationship between false and true? That's false, they have to be equivalent. True and false is false again, true and true is true, true and false is false again. So they're only true when they have this, it's only a true under there when you have the same value. Not A, not T is F, not T is F, not F is T, not F is T. X and not F, okay, so T and F is F, F and F is F, T and T is T, F and T is F, okay. And then in order to get the OR, I must get what's inside here first. So not T is F, not F is T, not T is F, not F is T. Then we have a disjunction, so only one has to be true. So T or F is T, T or T is T, F or F is F, and F or T is T. Then you have a disjunction to bring that all together. Well, you're going to look at the dot and you're going to look at the OR. So F or T is T, F or T is T, T or F is T, and F or T again is T. Okay, so are the values there, what relationship do they stand to the other values? Okay, so in fact, these ones here are, we're supposed to come out, should have come out equivalent, and did they come out equivalent? As to say, same on the one row, false implies true. Something happened there. What's up? That's for a second. Okay, everyone, I caught my mistake. You might have seen it too before I did. There should have been I meant to write an OR here and I wrote an N, and so that's the problem. So you have to do that part over again in light of, so true and false is false here. True and true here is indeed true. True and false here would be, false and false here would be false, and true and false here would be false. Okay, so now it seems as if they would be the same on every row, so if we get it right, so let's say these values then are going to change. Okay, so it's false and false is false, false and true is false, it's true and false is false, and false and false is false. So now you'll see under both main operators, 3 falses, wait a minute, it would be false or true. It should have been, sorry. False or true is true, and it's the same on every row. Okay, so so it's 3 trues. It's in the one case a false, 2 trues and a false. Okay, I've corrected myself yet again here. So the values under these, the main operator here are false, true, true, false, and under the main operator here, the OR, you'll find the same thing. How? You have false or false over here is false, and then you have false under the main operator here, or true is true. True under the main operator here, or any true or anything would be true, or false is false. And then you have F under the main operator here, and under the main operator here you have false or or false again, which is the second row here, because that's a dot. Okay, so false and t is false. So they have the same operator. So now that shows that the whole formula then is equivalent. Okay. Okay. All right. So let's try number 6. Okay. So now we're going to try number 6, which says H is equivalent to not G, G dot H, or not G and not H. And so again, we're trying to find out equivalent, consistent, contradictory, or inconsistent. So in this case, we can get the equivalence only after we've gotten the not G. So not true is false, not false is true, not true is false, not false is true. Is T equivalent to F? No. Is T equivalent to T? Yes. If F is equivalent to F, T, is F equivalent to T? No. I'm going to be using those values again, F, T, T, F, so I'm going to circle them for now. And then I want to get the values under G and H. I can get that now. T and T is T, T and F is F with a conjunction, F and T is F, and F and F is F. Okay, then I have to have not H, which is H is T, so not H is false, false, true, and true. Not G, not T is F, not F is T, not T is F, not F is T. Okay, so in order to get the dot there, I have to use the not sign here and the not sign here, those two columns. So F dot F is F, T dot F is F, T dot F is F, and T dot T is T. Okay, so in order to get the OR, which is the major operator of this second formula here, in order to get that OR, I have to take the conjunction here, the disjunction here, or take and do the same thing for over here. So T or F is T, and then I'm going to get F or F, which is F, and I'm going to get F or T, which is T. But F or F, which is T, for F is F, and then I'm going to get F dot T, which is F again. And so you'll notice that those values are always opposite. So this formula is contradictory. You'll find it to be contradictory on every row, which is to say, on every row here, F is opposite to the values that are here. T is opposite, F is opposite to, it should be opposite be T over here, shouldn't it be F or T, which would have been T, sorry. So that's they're opposite, so contradictory on every row. Okay. We should do one with 3 letters here, and so we're going to do number 8. All right, number 8. I have N dot A or not E, and then I have not A dot E or not N. Okay, and so there's going to be a dot over here, not A dot E or not N. Okay, so is that the way the problem goes? I hope it is the way the problem goes. I'm trying to check that particular problem. Yes, it is. That is the way the problem goes. Okay, I'll make sure it's up there. So under N, we've got, so you have 2 truth values and 3 letters, so 2 to the 3rd power is 8. 4 truths, 4 falses. Under A, true, true, false, false, true, true, false, and false. Under E, alternate true, false, true, false, true, false, true, false. Okay. Not E, false, true, false, true, false, true, false, and true. A or T or F is T, T or T is T, F or F is F, F or T is T, T or F is T, T or T is T, F or F is F, and F or T is T. And so I know that I'm going to be using that second row there. So T dot T is T, T dot T is T, T dot F is F, T dot T is T, F dot T is F, F dot T is F, F dot F is F, and F dot T is F again. So 6 out of 8, or 5 out of 8 in this case, were false. Okay, so under A, I should have put the 2 truths, 2 falses, 2 truths, 2 falses. And under E, I alternate true, false, true, false, true, false, true, and false. And under N again, 4 and 4. Okay, so I can do the not A. Not T is F, not F is T, not F is T, not T is F, not T is F, not T is T, not F is T, not F. Okay, there we go. Not N, not T is F, 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 T, 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 and T. Then I have to get T or F is T, F or F is F, T or F is T, F or F is F, T or T is T, F or T is T, T or T is T, and F or T is T. Okay, so I have to then get this conjunction here is the major operator of the second formula, so it's the negation line with the or line. So the not F, the not here with the or here, which is F, F again, T and T is T, T and F is F, F and T is F, F and T is F, T and is it T? Yeah, T and T is T, and T and T is T. Okay, so what do I find on these rows? I did kind of run them together rather closely here, but let's see what we can find about those 2 rows. T and T is the same, T and T is the same, F and F, T and F. If you go all the way down, you'll never find a row on which they're the same value, so they are inconsistent. That is to say, there's no one row on which they're both T. Whenever this was T, this was F, and whenever this was T, that was F. So you check the values on any one of the 8 rows and they are inconsistent. Okay, that's it for that section. We're going to skip 9, that has several more rows too if you want to try. I want to get to truth tables for arguments, that's why I'm moving ahead here. So 6.41, let's try truth tables for arguments. And here, the determination is whether something is just valid or invalid. So the choices are just those 2, and 6.41. Okay, so we have number 1 here, number 2 rather. It says in the problem, a high school principal, wait a minute, let's see what the actual problem here. You're going to have to edit this part out because I
Yeah,
okay, so I'm fumbling around here. Okay, if you look at, now we're ready, 6.4, Roman numeral 1, number 2, it's a word problem, and they give you the 2 letters to use. And the letters are, Brazil has a huge foreign debt, therefore either Brazil or Argentina has a huge foreign debt. So they give you B and A, so that's pretty obvious what they want you to do here. Brazil has a huge foreign debt, that's a premise preceding therefore. We know from premise and conclusion indicators way back when, that you separate the premise and conclusion with a truth table by putting 2 lines like that, and then you have Brazil or Argentina has a huge foreign debt. Well, that's intuitively plausible. It looks like a valid argument, but intuitively plausible isn't good enough. The truth table will tell you for sure whether something is valid or invalid. Well, 2 letters, 2 truth values, 2 to the second power, 4 rows, and true, false, true, and false. All right, we have our premise here. I'll put that row, well, column 1. I'm going to number these other columns here too, just for ease of use. True, true or true here is true, true or false is true, false or true is false, or rather true, false or false is false. Then you're going to ask yourself, does this premise imply this conclusion? You're going to use an implication between the premise and the conclusion and keep the values under the double vertical lines. So true implies true is true, true implies true is true, false implies true is true, false implies false is true. What do we call this? This is from the previous exercise. If we were being asked this, we'd be told it's a tautology. But here we're just saying it's valid. That is to say, if it was invalid, I would have found some row on which there was a true premise implying a false conclusion. So I'm really looking for this. Because T implies F, we know by rules of implication, T implies F is F. So I'm treating the premise as the antecedent part here, and the conclusion as the consequent of that conditional, and asking, does the true, is there ever a true premise combined with a false conclusion? Well, no. True implies true, true implies true, false implies false, false. Those are all true, and so this was a valid argument. So that's what you're trying to do with the truth table. That argument will always work. Okay, so number 3, they're moving you right away to 3 letters here. So let's get it set up for 3 letters. Number 3. It says, if fossil fuel combustion continues at its present rate, then a greenhouse effect will occur. That's F implies G to me. That's period. So a new premise is coming. If a greenhouse effect occurs, then world temperatures will rise. So separate the first premise from the second by, if greenhouse with a single line, then world temperatures will, W. And then it says, therefore, if fossil fuel combustion continues at its present rate, F implies then world temperatures will rise. F implies W. So if F implies G and G implies W, F implies, that also has an intuitively plausible ring, hypothetical syllogism that's valid, but you have to do the 8 rows to figure this out. So 4 T's and 4 F's under the first variable, F, then we alternate 2 and 2. And then under G, 2 and 2 again. And then under W, you're going to alternate T, F, T, F, oops, T, F, T, and F. Under F, we've seen that before, so it's 4 trues, 4 falses. Under W, alternate true, false, true, false, true, false, true, and false. All right, T implies T is T, T, F, F, T, 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 and T. So that's the premise in my second row, my premise. In the 5th row is this going to be this major operator here for the next premise. True implies true is true. True implies false is false. True, true. This is true. I'm just looking to see if true implies false is false. True and true. So under row 5 is the second premise. Do they imply the conclusion, which would be, I'm sorry, column, I can call it rows, columns. So true implies true is true, false, true, false, true, 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 and true. What you're looking for now, this is the first premise, this is the second premise, this is the conclusion. Is there a case where both premises are true, like this, and the conclusion is false? If so, you've proved it invalid. That's your kind of shorthand. You're looking for that. But you probably won't find that. I suspect you won't here. True, 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 so that's true on that row. True, false here, so you can skip it. It has to be 2 true. False in the premise, you can skip it. False in the premise, you can skip it. True, true on the 5th row, true here. 6th, true, false, you can skip that. True, true, and true again. True, true, and true. So here we have the problem completed up here. Just let me say a few things about it and what we were looking for. Okay. What we were looking for is some combination of premises and conclusions to prove this valid or invalid. In this case, whenever you have two true premises, true and true, lined up under the columns designated, and a false conclusion, that's called invalid. But you didn't find that here. Whenever you had true and true on any one row in the premises, premises being columns 2 and 5, you found a true in the conclusion, and that's valid. This goes back to the beginning of the course and some terminology there. I think it was chapter 1, in which an invalid argument would be one in which the premises are true and the conclusion doesn't follow or is false. So a valid argument is one in which if the premises are assumed true, the conclusion must be true also. So in this case, we have a valid argument by definition. Okay, everyone, we're going to try number 5 together. The thing I would, slow it down a bit. I read through the problem. If high school graduates are deficient in reading, they will not be able to compete in the modern world. So there's a negation there. That's one premise. How do I know? There's a period. It's ended that thought. If high school graduates are deficient in writing, they will not be able to compete in the modern world. That's a second premise. It's also followed by a period. Therefore, that must be my conclusion. If high school graduates are deficient in reading, they are deficient in writing. So, if high school graduates are deficient in reading, that's R, then they will not be able to compete in the modern world. So not C, you'll be given the letter C, you can use that. That's the first premise completed. Write it down. The second premise, if high school graduates are deficient in writing, they will not be able to compete in the modern world. So if W, then not C. Therefore, if high school graduates are deficient in reading, then they are deficient in writing. R implies W. We don't know intuitively if that one's valid or invalid. You're going to have to do the truth table. And we have a circumstance where it's 8 rows again. Okay, under C, 2 and 2. Under W, and under C again, we're going to do 2s. Under R, 4 and 4. And under W, okay, so we can take the value for not C, not true is false, false, true, true, false, false, true, and true. In order to complete that premise, I have to do these columns here. 1 implies 3 will give me what I need. So true implies false is false, true implies false is false, true, 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 and false implies true is true. Okay, so then we have all the values there for that one. Not C. Okay, true implies false is false, true implies true is true, false implies false is true, true implies false is false, false implies false is true, true implies true is true, false implies false is true. And needing that, those were columns 5, 6, 7, and 8, 9, 10, and 11 over here. True implies true is true, false, true, false, true, 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 and true. Okay. All right, so let's look at all rows and see if there's a combination of 2 truths and a false on some one row. false, false, and true is true, false, false, and false again is true, true, false, and true is true, 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 and false. Looks like the fourth row, I have found a case where both premises are true, and the conclusion, in fact, is false. So that all you need to do is find one row. If you find it on more than one, it's not required. But here you had a true in the premise, you had a true in the premise here, and a false in the conclusion. So that argument, number 5, happens to be invalid. Okay? Okay. Let's go to number 6. Okay, everyone, I've set up the columns for 6.4, Roman numeral 1, number 6. In fact, this is 6.4, we have a number 6. Okay, so in this case, the problem reads like this. The disparity between rich and poor is increasing. You're supposed to label that D. And you go right from that to the conclusion. Therefore, political control over economic quality will be achieved, P, implies only if restructuring the economic system along socialist lines implies that there's a conditional that political control over economic quality will be achieved. So P implies R implies P. I filled in the values already for the many of the letters and operators, but we can go from here. We can label the columns, and for ease of use, you don't need to do that on a test to show that you've solved, to solve the problems. But we have to get P. 2 implies 5 in order to get 3. So I'm going to put 2 implies 5 up there. The antecedent implies this consequent. So true implies true is true, 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 and true, 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 and true. Okay, so does 1 imply 3 in this case? And this is where you're going to put the values under the double slash. So true implies true is true, 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 false implies true is true, false implies true is true, false implies true is true. If they're true on every row, we know it's a valid argument. So you might not have been able to tell without a truth table if that was valid or invalid, but with the truth table, you can. So it's a valid argument. We'll try now number 8, and one more with 3 letters. And I'm going to stop there so I can fill in the values, so you don't have to do all that. Okay, everyone, this is number 6, and I filled in the values, and you have here. Now, I'll show you how I arrived at that particular wording. Actually, this is number 8, I meant to say. If microchips are made from diamond wafers, then computers will generate less heat. M implies C. You were told to use those 3 letters, M, C, and S. You'll notice in parentheses at the bottom. Computers will not generate less heat, and microchips will be made from diamond wafers. That's not C.M. And then, therefore, synthetic diamonds will be used for jewelry, synthetic for S. So you need, with 2 truth values and 3 letters, 8 rows. So under M, you're going to put 4 truths and 4 falses, as I did. Under C, you're going to alternate 2 and 2, so 2 true, 2 falses, etc., all the way down. Under C again, 2 truths, 2 falses, all the way down. Under M, 4 truths and then 4 falses. And with the last letter, S, you're going to alternate true, false, all the way down. Then I can solve for column 2. Number these. I can solve for column 2 by 1 implies 3, true implies true is true, true implies false is false, true implies false is false, false implies true is true, false implies true is true, false implies false is true, false implies false is true. So, so in my first premise, I'm going to be making use of these values, that I know. And then I have the key operator is here is number 6. So in order to get 6, I'm going to have to do 4.7. All right. So it's 4, the negation sign, and then a conjunction of 7. So F and T imply F, F and T imply F, T and T imply T, T and T imply T, F and F imply F, F and F imply F, T and F imply F, T and F imply F. Okay, so I know I'll be using that as my second premise. So I'm going to circle that entire main operator under the second premise. The conclusion, circle if you wish, is there. So what am I looking for again? A case in this premise where there's a true, the second premise is a true, and the conclusion a false. If I find that combination, it's invalid. If not, it's valid. TFT, that's T. TFF, that's T. F, you can skip it. F in the premise, skip it automatically. Fifth, T, T, F, and F, true in the second, skip it. So that's already good. This is all good. Sixth, true, false, and false. That's also can be skipped. Seventh row, true, false. Eighth row, true, false, and false. So in all rows, that is, it worked out. There's no case, in other words, where you had two trues and false on some one row. If you found that, it would be invalid. But you didn't. So it was valid. Okay? So I'll try one more with, they give you one more, number 9, with has just, number 9, it's, yeah, the USS Arizona one, number 9. There you just have several letters. And that's the last one we'll be doing for today. I'll do more in the middle of the week. I'll give you a study guide on the 23rd. That's Thursday for the exam on the 30th. Okay? And I suspect there'll be at least one more video after the one on Thursday. So Wednesday or Thursday. So you'll have enough practice. Okay. Now the number 9 here in this section says, either the USS Arizona or the USS Missouri was not sunk in the attack on Pearl Harbor. So either the USS Arizona or the USS Missouri was not sunk in the attack on Pearl Harbor. Therefore, conclusion, it is not the case that either the USS Arizona or the USS Missouri was sunk in the attack on. So it is not the case that either Arizona or Missouri was sunk in the attack on Pearl Harbor. So by De Morgan's law, that's a conjunction, by the way. You don't have to know that yet. This is a disjunction. I doubt this is going to be valid. We get some break here because there's only 4 rows. 2 trues, 2 falses. Why? Because it's only 4 letters, 2 letters. So true, false, true, and false. 2 trues, 2 falses. And under M, true, false, false. Okay. Not A, not T is F, not T is F, not F is T, not F is T. Not T is F, not F is T, not T is F, not F is T. 5, 6, 7, 8, 9. So in order to get 3, F or F is F, T, F or T is T, T or F is T, T or T is T. Okay, and then in order to get the negation under 6, we're going to have to do 8 first. So T or T is T, T or F is T, F or T is T, F or F is F. Then we get the negation of 8. So let's put that there, negation of 8. Not T is F, not T is F, not T is F, not F is T. Okay, so it's those 2 columns that I'm going to be looking at. And does F imply F? Yes, that's T. Does T imply F? No, it's false. What I found then, I'll find it on the 3rd row too. Next to the 2nd row, just mark it off. That's where you had a true in the premise and a false in the conclusion. So this argument is invalid then, because we found a row where the premise, T, implying the conclusion, F, meant F. We found at least one row where that was the case. It's also true on the next row, 3rd row, but you don't need, you can stop it as soon as you find it to be invalid. Okay, so start the next set of exercises on the syllabus. and we'll look for we'll be entering chapter 7 before long, but look for another video and a study guide, as I say, on Thursday. Okay, so have fun with these problems. Take care. Bye.